Hello.
Hello, hi team.
Yeah, hi sir. Am I audible?
Yeah, you are audible. I am audible. My voice is clear.
Yeah, sir. It's clear.
Okay. Okay. Okay, let me know when we can start.
Yeah, sir. I'll give a introductory talk. After this, you can begin.
Yeah. And just want to know, let other participant mute while we go on for the next 1 hour, and last 15 minutes we can unmute them.
Yeah, sir. We have told that.
Okay, thank you.
Okay. Good evening, everyone. Today's webinar on design verification will be delivered by Vaibhav sir, who is working as a senior design verification engineer with strong hands-on industry experience. He will be sharing his practical insights into DV that are extremely valuable. So before we begin, I request all the participants to keep their microphones muted. And at the end, as Sir said, we'll have a 15 minutes of Q&A session. You can ask your queries then. Sir, now you can take over the session.
Okay, thanks Silicon Sandbox for inviting here. Today's session will be talking more about the more aspects of the design verification and how a fresher, a college graduate, or the early professionals who are already in this field need to have their basic understandings or the interview preparations to be on track. So during this presentation, I will be sharing you the few of the examples, what we do exactly in the design verification in industry. As well, we will also talk more about the other aspects such as AI, or what career growth exactly you can expect in the design verification. So before I start, let me share the screen, and so my screen is visible, right?
Yes, sir.
Okay. So if you see, as a VLSI engineer, VLSI is not only about the DV. It's about from we start from basically from the RTL, right? Before that also we do few modelings, and we start with RTL and we end at GDS2. Somewhere between we reach to the DV, which is design verification. So what exactly we do here, whatever the RTL we write, that is basically .v format we write, right? Most of the cases. And we check that whether what we return is correct or not. So basically we will check all the inputs, what we are possible inputs we give basically in the simple language, and we'll check whether all possible outputs we achieved or not. So this is the simple funda we use in this design verification. But current industry not only required that, current industry requires something beyond this. So what exactly? So in the real world application, we need more sound knowledge of basics understanding first, and then we want to use some advanced algorithms. Algorithms, when I say, I'm talking about AI and ML algorithms. So when we see that algorithms, when we use this algorithm, then only the today's complex chips or SoCs are possible to make or verify it with the languages. But languages eventually remain same whether you are using any AI algorithms or machine learning algorithms. So it is always make a very clear sound knowledge of the subjects which are very basic. So what are the subjects required? I will talk in furthermore slides, but I think if that concepts are clear at your subject level, then you can move on to the next levels. But I am observing in industry, number of transistors nowadays in the complex SOC chips are increasing like anything. So to verify that, we need a people or a freshers who have made it possible while doing that. So to that, we want a fresher to ready for that. So this webinar, I'll be talking more about what we need. So your motivation to pursue these domains should be you have a little interest with coding background for design verification. And if you don't have also a coachings like Silicon Box or coachings which are available or the sources you can available can make it possible. So what exactly we need, we'll see that. So these are the basic roadmap to start studying the VLSI design. These are the common topics. If you are from DV, you are from RTL, you are from physical design, you are from synthesis, or you are from modeling teams. Any team you are going or any team you are targeting, there are some basic understanding you should have to learn them without any prerequisites, right? So that's where the skills comes into the picture. So what are the skills they are? The first skill is digital electronics. So as an undergraduate student, many are your undergraduate students, they are already aware about that. Key, what's digital electronics is. Digital electronics is a simple funda where we use a logic designs, Boolean algebras, combinationals, and sequential circuit to make a complex design. So this is very, very basic things. And I think digital electronics, if without digital electronics, we should not proceed. Keep in mind, these are the 4 ultra high priority cases, I mean subjects, which we needed. So to have the strong coding is the secondary part, but to have strong concepts is the first part. Second is basic electronics engineering. We should be aware about the what exactly in a circuit, electronic circuit, what exactly voltage plays, where the current plays role, where the exactly resistance plays. Because when we go to the from the abstraction levels, when we go to the higher abstraction levels in the designs, right? We should understand the correlation between each of the models in the design, right? What each model do, where is the clock is coming from, where is the reset is coming from, right? That understanding is for sure required. So that's why a basic electronics engineering is required. Next, as we know, when we talk about the VLSI industry, we talk about basically a transistor at a very base level, right? So which are nothing but the building blocks or integrated in the integrated circuits. So we talk about the transistor. Transistor is nothing but one device, and basically we call that as a semiconductor device, right? So diode, transistors, or MOSFETs are the building blocks. Next is the SDL codings, hardware description language. If you know the MOSFET, then how to model that part will come into picture. So we do the HDL codings, whether it is Verilog, whether it is VHDL, whatever it is. It's the steps to learn. First, you can start with VHDL, later you can go to Verilog. But as per my experience, there is no dependency if someone completed these 3 and can directly move to the Verilog. It's up to you. Modern syllabus in many of the universities already cover these basics, but the most lack moment is people make it by heart without understanding the concept, basically at a college level students. So I request each one of you, if you know the fundamentals of these 4 in very well manner, then going into the Verilog, making the one step ahead in the design verification. Because from the decades we are observing that the simple designs or the RTL we are able to see are mostly in the STL format or Verilog format. We simulate that, we design that, right? So after designing, once we design, RTL designer has designed it, then only the part of the design verification guy will come. So once you grasp all of this, you can switch to learning the VLSI technology basics. So if it is DV, if it is PD, if it is synthesis or any of the modeling tips, Verilog is a must-know language, and I know most of you may be aware of that. So if you connect this all 4 dots, these are the 4 dots. If you connect all these 4 dots together in your mind, then you are get ready to go as a design verification engineer. So what exactly we can do at a micro level? If someone asks me what exactly we can do at a micro level apart from these four, so I suggest you to do the microprocessors and microcontroller, get the basic understanding of op-amps, RC circuits, and a resistor, inductor, and capacitor circuits, RLC circuit. Because if you go to the more complex SOCs in the nowadays, the basic building blocks inside these circuitries or inside these chips basically remain same. If it is digital part, the digital circuit will remain same. If it is analog parts, then op-amps, RL or RLC circuit will remain same. We cannot replace them. But this understanding of complex SOCs, you are only able to understand once you know the basic fundamental blocks of them. So for digitals, basic fundamental blocks are like microprocessor, microcontroller, you can say. For analog side, we can say the op-amps, RC and RLC. Now, along with this, we need a few scripting skills. What exactly scripting skills is? Scripting skills is nothing but, let us consider there is a person A and there is a person B. And your boss has assigned you with one task. This is person A is doing that task, same task is assigned to person B. So scripting skills will come into the picture when task has some repetitive information to extract or repetitive information to do. So let us consider person B knows the scripting, person A do not have idea about scripting. Then to do that redundant task, he will manually do every setting at his level. But person B will use his scripting skills and he will reduce the manual efforts. He will write some procs. Procs is nothing but a task in scriptings. Procs. He will write few procs and he will make the complex works to be easy. So to give this example, I will give an example where exactly we can use the scripting skills. Let's consider there is in the RTL, if we say there are a few registers, which is in most of the RTLs, industry level RTL or in normal level RTLs, we have few RTL registers present. So that RTL registers, if we want to do a coding, I mean, if you want to find out few of the register address, which is belong or start with 0 to 2. Then if lakhs of registers are present and they are randomly parsed in the file, then a person A will manually waste his whole day to find out what addresses are present at each locations. But if let us consider you are a person B, you know the scripting language, then you will give a script, parse script that you will write first. You will say your script, I want this width to be extracted. This is just a simple example. Okay. Just a simple example, but use case can be more high level. So you can ask person B and person B will finish this work in 10 to 15 minutes. Then in that case, we target the efficiency at the end of the day. So efficiency of this person will be obviously more. Okay. So that's where the Tickle and Pearl will come. What exactly Tickle and what exactly Pearl, you can go through. That's not the part of today's discussion, how the concepts comes. But hello. I see someone unmuted. Okay, let's go forward. So there exactly Tickle and Pearl come into scripts, right? So you will be writing. So I want you to choose only one among them. If you are, as per my understanding, if you are targeting the front end part of the VLSI design, then you should target the Perl scripting. If you are targeting the most backend, but yeah, Tickle you can use. But basically, one of them you can use. But modern system also you can expect easy level of understanding and coding. then I recommend you to go with Python. That's also okay. So among these three, one is okay. You can use any level of scriptings for this, but among this, one you choose, practice for that. That's easy. So what are the study sources? If you ask me where I should study this all, then you have the classes where we conduct a sandbox Silicon. These people also have the good classes for the Verilog, system Verilog, or the digital electronics and UVM trainings or scripting trainings, right? You can follow them, or many of the resources are available. There is no limit on that. But what is lack? Reading that material doesn't help, or understanding any classes doesn't help. You have to solve as many as questions possible. So when you solve the quality of the challenging question, your thought process will eventually increase and increase. And simply, I mean, a direct formula bends one. So elevated the simple problem doesn't make anything. The complex solutions which you face in day-to-day lives, that solution when you try to implement my RTL code, that makes. If someone want to go, where should I go? Point out that questions. Where I get the challenging question. Then you can directly search for the lead course or any of the coding background websites directly, and you can try making the common algorithms to be coded in RTL design if someone wants more challenging. But before that challenge to accept, you should know the basic fundas. You can code all the digital circuits, all the combo and sequential circuits once. Then you can go to the one challenging part. If someone wants to go some research-oriented questions, if you want someone to go something called practical approaches, then you can start doing the gate questions. You can see you can search LinkedIn for the many of the questions available. You can try to attempt that questions, or you can see the NPTEL course materials, right? So always quality over quantity always win. So complex problem will take the time, but which test your concepts and good ticks always take time. We know that. So these are the basic fundas we need now. What are the opportunities as a VLSI engineer, and what are the free opportunities you can try? I can say, because sometimes we are waiting to opportunity to knock our doors, right? So there are few competitions or the summer opportunity. Now summer is approaching. So you can search for these two very fundamental opportunities, even very famous in industry, because these are the opportunity which test your coding skills basically. So there is a design contest, okay? So which is conducted by Cadence, right? So you can directly search Google about Cadence design contest, and you can get deadlines and possible ways. So this is one way that you can prove yourself in the industry, where you can get the contact with the industry persons, peoples. Then second is innovation design challenge. So with the Texas Instrument and government, this challenge is mostly like entrepreneurship, where the electronic design can be submitted and where you can innovate yourself as per your creativity. So problem statement is given to you. You can directly search Google for it. Problem statement is given to it, and you can try to correlate the problem with that problem statement, how we can proceed for the logics. These are the opportunities where you will come across the industry to touch in with. So you can note these two: Cadence Design Contest and India Innovation Challenge Design Challenge. So they will give you the real-time problem statements. They will give you a clear-cut idea what you have to do. Just you have to apply your concepts that we use. They are like business challenges, or they are like hackathons. Okay, but someone will ask me, by doing this, may I earn? No, you won't. So I have also 2 scholarships for you, which are paid, right? So these are the like summer internship I am sharing, because next year you will be having the summer. After 1-2 months of preparation, you will be having the summer, right? So you can see the mentor wrapping especially takes the open challenges as a very long internship. So it is provided for the 2 months. There no stipend is provided, but where you will get free trainings. Now there is also DADY scholarship. This is like a scholarship awarded in the Germany, basically for 2-3 months, and they take the test before that. and you can directly search on Google about DADY scholarship. So it is only open for the college registered students, right? And you will get an opportunity along with scholarship here. So this is as a part of earnings you can do along with the knowledge part. But to achieve this all, basic fundas are a must. If you are lacking in the basic fundas, then discussing about these challenges will be pretty difficult, guys. Let's move on. What about a project and research opportunity? There are the people who says, I want to do some internships because I want to gain what happened that industry, how the project works, how the real design verification works there. So if you want to do the research oriented internships, you can try for the higher level educations where we should apply and get the good exposure at the research work going on in the VLSI field. So you can search out for any of the IITs or IISc's official web pages. Also, project under guidance. It's always matter that what projects we will add in our resume, right? Will play the role because you can expect many of the questions from your resume itself. So what questions they expect? It's mostly based on the projects you have done in your past career. They will check your fundamentals, then they will jump on the projects. So I recommend get the touch with the industry people who are already work because everyone follows the same cycle. They will study, they will achieve something, and they go to the industry. Once they go to industry, they get industrial exposure. So as a fresher, I recommend get in touch with the industry people. What's going on there? Ask them some project critical ideas. If you are able to do it, well and good. Or ask them what exactly happening with you and where you are lagging. Their potential approaches may solve you. So it is nothing but a project under guidance. You can ask them a specific digital related. You can ask them specific PLL related. You can ask them specific analog related projects. It depends on your area. If you're specially targeting design verification, then you can ask them specifically about you can ask this specifically about RTL, get the RTL from them, try to verify that. So in that way, but before going one step before, you make sure that you know the basic fundas in a very clear way. You can also ask them for FPGA related, FPGA prototyping related projects, or what kit you can order by your own and try the LED interfacing, or you can try the few digital related circuits on the FPGA boards if it's possible. If you're already college going and you have already FPGA board available in your libraries, take the use of them, make it interface with your system and try to see what you code, whether it, because this will give you the another level of pleasure when the code you have written is executed successfully without any errors on the FPGA boards. So I hope you guys already know the FPGA board, that is field programmable gate arrays. And if this project under guidance is successful, then you can try for the few conferences which happens in the VLSI and try to get your work published and showcase that, which eventually make our resume itself a stronger. Now, so what about internship and job career pathways? There are major MNCs in VLSI companies, right? There are few EDA companies and there are few service-based companies. So targeting any of these companies has no problem. It depends on where you apply, where you get the opportunity at initial level. Later in the career, you can go and check with all the MNCs available, all the EDA or all the service-based companies. But getting into the industry is the first step now. Now, in very few cases in VLSI, internships are available for 2 months. You need to exclude and make yourself available for 6 months or 1 year. Most of the cases, as an intern, you will join as one organization, and later within the time you got a very good opportunity and same organization, you will get a chance to convert as a full-time employees. So there are different job roles which goes, but basically as a design verification, there are different stages that we will see what exactly as a design verification engineer we need to do. So So it depends on the company, and since it is specialized domain, right? As a VLSI design verification, pay is quite handsome. I just want to give you that. Right now, so how you can be joined as a DV engineers? So you can use these are the secure positions, which are like on-campus job opportunities. Then you can see the company job portals. Even you can try for the applications or job posting, messaging relating to people, joining the people on LinkedIn. Then there are few sites available. You can go by referral also, or there are common company drives happen in offline mode. You can try for that. If any of these positions you got, it's all about the opportunity. So these are the things you already might be knowing that if you want to upskill as a undergraduate, you have to go with a few of the exams which happen as to check your graduate level of the graduations. I mean graduate aptitude examination. So where GATE comes, where engineering service comes, where the GRE comes. So it has, you might be aware of this. So these are the future where you can mind your future in a very, or create your future in a very well-known manner. But important points in that, keep it technically, right? Your resume should be very technical in that. Keep the sections very clearly in your resumes. These are the resume points, and highlight the academics. Let with the optimal line, okay, and highlight all the academics. So these are the some resume preparation techniques I want to give you. You can think for this resume preparation techniques when we make the resume for the design verification roles. Now I will be targeting more about the design verification. No one knows, we will wrap up as a VLSI now, right? Now, as this is specially made for this webinar, is specially made for the design verification. For the few times, I will wrap up for the design verification. Let's see. So what as a design verifier, we ensure that complex chips or design go very in the chip designs where GPUs, CPUs go very flawless or without any problems. So critical steps happen before the physical manufacturing basically. So DV prevents costly errors and accelerate the product launches, because design verification, let's consider this is one RTL, right? And it is outsourced for the silicon. At the end of the day, guys, RTL will be a silicon, or you can say will be the chip, right? So a DV role is a most crucial role. Why? Because because at the end it will go to chip, and chip is very costly to manufacture, right? So what DV do? DV will find out flaws, errors, or logic mismatches, or issues in the functionalities, right? In this RTL. So DV's role is the most crucial role because we accelerate the product launches, right? So we use, and as a DV, we use, you guys already know, a UVM and system Verilog to check the logics. We use the industry standard stimulus, right? Synopsys VCS and the cadence incisive to check our whatever using this tools we are using in industry, using these tools and using this methodology we are using in industry to check the RTL codes. This is the more advanced level we can say to talk now, because I will go on this later on the functional coverage part. So guys, basically when RTL designer codes is right, he gets some specification. Specification is nothing but he get some idea about design and he code it into RTL, right? Same specification, right? DV also guy will get. Let's consider if in an example you have to just develop one mobile processor, right? So what speed it should work? What is the trade-off it has to do? What are the feature it has? At a high elevated temperature, what was the possible conditions this processor will do? These all points will be described in the specification. Using this specification, RTL design will code that, right? Same specification is passed to the DV engineer. What DV engineer will do? DV engineer also will read this specification, find out his scenarios, will check on this RTL, right? So basically, and at the end of the day, what's his target? He will check whatever written in the manual or a data sheet or a specification is covered or not. If it is covered, means we can say all the 100 functional coverage is covered. If any of this is not covered, then it's the DV specific guy is related to that. So it's like there is a gate, and to pass this RTL to the silicon, and this gate keys are with the design verification guy. If you open the gate, then only it will pass to the silicon or a chip. So this is given in the dollars, right? Now, senior roles often expects more than this. Now, so engineers advance quickly and often specialize in the advanced verification methods. This is the basic things as a DV engineer. So as I already talked about this, I just want to give a clear idea, understanding what's exactly as a DV engineer you will do. You will ensure that semiconductor design work perfectly, whatever design is given to you. If it's particular blocks given to you, then you should understand its semiconductor design work perfectly. You also check to prevent the critical failures, saving the million in the potential cost by manufacturing at the silicon level. As well, you will find out the corner cases that can I check, and I can get the maximum flaws, and before I open the gate for the silicon, I can get the issues. As I told, we get a specification from a designer and RTL, right? Then from that, we find out scenarios that we can check. That scenarios is nothing but we call a test plan. We call a test plan. So this test plan has a number of scenarios that you can check before you open the gate for silicon. Now this test plan has some criteria that every industry follows. So as a DV engineer, your first task goes with creating the test plan. What are the possible scenarios you can check? Once you check that scenario, then you can again come to your test plan at the end of the day and check all scenarios are covered or not. So we aim for, as I told, 100% functional and code coverage. Whatever the code coverage is nothing but whatever the code we have, all lines should execute, or your stimulus should execute the all right. Functional part is nothing but whatever the criteria we decide in the test plan from the specification, it should cover all the functionality of particular model. Now, there is also the key roles to validate the design, finding and fixing the errors, and drive the project success, right? So to build the test environments, we use the tools like QVM or methodologies like QEM to test the complex digital design. We find and fix the errors systematically. We identify the design flaws. We find out the design issues using the system Verilog. And as per observation, I found that it escapes over by the 20% if you find out the reduce the critical bugs. And eventually at the end of the day, we go to the drive the project success. So one most important part in the industry is time to market. If you're able to trade off with your skills, time to market, then at that time that particular industry succeed or particular organization is succeed. Because there are a cheap giants who are available, they fight each other to get their product to be launched first. So to validate the design as a design verification engineer, it's your job to make it possible with a strict rules or schedule or deadlines. So what we do the sharp analysis, we create a test plan, we run the simulations, and we debug the complex problems. So they're careful about preventing cost errors and saving millions and ensuring reliably products the modern power technology or modern technology. So these are the core verification activities that I am going to talk now. I have given you the top ideas, right? Now I will go to the each one of them, what the core verification activities at industry we do to check our design is correct or not. First activity, as I told, RTL designer codes the RTL, right, from the specification. So this same specification is passed to the DV engineer, right? Let's consider this specification will come to you. Then you will create a test plan for that. Your test plan guide a design that what scenarios can be done. Detailed scenario you will write. What to test. Depend on your scenario intent only, you will able to code the sequence. What you will write at a UVM sequence for specific functions. Now, you have to meet the standard minimum and maximum possible combination given in the specification. You have to mimic in your simulation. Because after the specification, you will get RTL code, right? You will create your TB. And once you are clear, you will do the coverage, right? In this broad, in the top view, I can say, and you will open the gate for the silicon. This is the simple process, right? It looks simple, but it has many chains inside that. So we aims for zero bug at the end of silicon, right? So let us consider you have defined the 10 test cases, right? Then you have to simulate or mimic this in your bench to send the stimulus for this RTL. And at the end of the day, you need to check at the code level, code coverage is covered. At the specification level, whatever scenarios you tried, for them functional coverage is covered on. If both are matching, if they are 100 and you make it clear with your designer, let us consider both are matching, both are 100, make it review with your designer, then we can say it is go to silicon. That's the common chain of cycles we follow to get the silicon ready. But it has also many other fundas, right? Let's consider this silicon is ready. Okay, then it will go for the post validation. What we do at the post validation, we send 80 patterns at a DFT level. We send 80 patterns. We check whether all the patterns are passed. Then in that case, let's consider the post validation guy find out issue in the few of the functionality. Then he will come to you because you have verified at simulation, right? Then he will come to you. Then you should able to mimic that scenario from your test bed if it is possible. So in that case, you can give the confidence. This coverage can give you the confidence that this issue should be avoided. Now, let's see what essential verification process go. Essential verification process goes from writing the test cases, right? From running the simulations, from debugging and troubleshooting. Then we go to coverage analysis, as I told. Then we go to regression testing. Why we go for regression testing? I will talk on that. So we create a test cases to check all design functions has specific patterns and interactions. I told you, writing test cases. That test cases, we convert it using our design methodologies team, like UVM, or we use SV. Normally we don't use, we use UVMs to running that simulation. Modern industry also uses this PyUVM, right? Which is the UVM based, Python based UVM methodology. You can find more it on internet for this. This is the modern UVM, and most of the traditional approach goes with UVM. Now, we run the test cases with the standard simulators. We review the result to confirm design works. Then we do the debug and troubleshoot. We use special tools to find and fix the bugs fast. and helps to reduce the spend on debugging. So this go in a stepwise manner, writing test cases, running simulation, debugging and troubleshooting. Then then we go to the coverage analysis. As I already told, we check for both functional part as well as we check for the code coverage part. Then we automate the test to check a new problem. Because do you know, let's consider this is your design. Why we do regression testing, I'm saying. And RTL guy has updated few code and you have verified your test cases with the previous code. Then he had changed his logic. Let us consider. He had changed the logic. Because of that, it throws error and you don't run your test cases on latent design. So we recommend at industry practice to automate it, that when every design change, we should run all the test cases. That's the basic one. So it's like ensure the quality with little human efforts, right? So whatever the design versions will change, right? Until guys modified, let's consider design logics. Then as a DB engineer, you will run your all test cases on that. So running all test cases, what you define in the test plan, right, is nothing but the regression testings. Now, as a career path, as a fresher, you may have a question that how, as a DB engineer, what are the key roles, I mean, key milestones you can say in the career path. So there are the entry-level engineers, then the mid-level engineers, then senior levels or managers and adjusters. This is experience is just for the illustrative purpose, right? You can consider this experience just for illustrative. So what exactly job roles changes when we achieve a particular milestone? So as an entry level, if you enter, you will execute the existing test suites. You may not get the work from the scratch, but you will get the idea of the fundamentals, how we can use that. Then you will write the basic test for your RTL logs. Then you will debug the minor waveform related issues or simulation related issue, you can say. Then one level up, when you have 2 to 5 years of experience in the industry, you will be develop some compressive UVM test benches based on the RTL changes or the new protocol. You may get the chance to learn the new protocols which can use the modern SOCs. Then you will go one level up and you will be doing as a leading role, you will be architect the full SOC environment. SOC is nothing but system on chips. So different IP blocks will come together, right? Form the total chip is nothing but the SOC. So powering the SOC, you will do powering the SOC, making it define the methodologies at the chip top level, right? Chip top is nothing but SOC top. So you will collect the coverages from all these blocks and making your total coverage as 100%. So when you go to the director, you will be moreover at the managerial level, you will be doing some tool reference procurement, or you will be doing some team efficiency like activities when you go to the higher levels of the experience. But this is the experience where you would technically involved, right? And you will be you will utilizing your basic concept as a DB engineer. So most of this experience is just for remark, right? Now, let's go. What are the career growth opportunities? So if you see the clear career path from engineers goes to the leadership roles. So these are the specific tasks that I mentioned previously that at every level you will do. So from entry level to the experienced leaders level can do this different tasks. But to get into the industry is the first point. For that, what are the basic concepts I told you? That is for sure. Now, let's conclude what's the career path is. Exactly we go. So as a career path, we talk accelerated careers and compensation. So this gives us a mind happiness when we see the compensations is very high in our industry, right? Once you enter it. And these are the different milestones. Once you achieve that, you will accelerate careers. There is also industry impact, right? Ensure high silicon quality. I will be talking about AI also furthermore for the next 15 minutes. So we we costly reprints using the advanced verification, and when you see the something you have verified is in available already in the market, then that level up or boost your the industry impact. Now, there is already, as I told in the VLSI, there is a continuous technical evolution because technology node is reducing nowadays, right? We are going 2 nanometer, even below that. So in that case, you have to be always technically involved in this field. You never get a job which doesn't check your impact of your concepts. So basically, dynamically and intellectually simulating works you will get most of the times. Now, most important part that most of the freshers worried about, that is AI and machine learnings in design verification. I will talk on that. Let's see how it goes. So we use some AI algorithms or a large language LLMs models in the modern designs. How exactly we use, we'll see. So I have the few real-time examples that I want you guys to be aware what exactly the AI models we are going to, or the large language models or LLMs we can use the modern chat GPT-4 or above that, how that impact, or what are the search engines that algorithms we can use to make our task and then match to the technology node, or we can say how we can reduce the simulation cycles with this modern models or artificial intelligence techniques. We will do this. So there are some challenges. Because of these challenges, only we move to the AI. So first we should know the challenge. So I will talk about challenge. As I told, we use UVM for verification purpose, right? So there are some challenges with UVM which needs AI or ML algorithms to attach so that we can make it time to market very less. First, we talk about design complexity. Do you know that hundreds of heterogeneous cores or the diverse functionalities from modern SoCs? So many IPs with a PPA requirement, power, performance, and area, we made the complex SoC possible. So there are millions, billions of transistors seated in this SoC, or you can say in the chips. So at this point of time, as a DV engineer, getting the knowledge of whole designs is not possible unless you have experience hand on that. So we use AI ML techniques. So what are the techniques? We'll say it on the SoCs to make our task easy. We use the extended cycles, like extended cycles in the sense, if you see from RTL design or RTL modeling to the silicon, the most of the time goes, means as a DV engineer, you will be working from RTL design to the silicon level. I mean, your part of the chip will be more. 70% of the overall chip design cycle, you will be involved in that particular project. But if you consider a PD guy or synthesis guy, his job will be limited at this point. Once it come to him, a netlist will come to him. From RTL, it will convert into netlist. When netlist will come to him with synthesize, then only his job will start. But as a verification engineer, you will be starting from specification. At the end of the silicon, you will be involved. So there is an extended time. So due to this, there is a delay in time to market if you unmatch any of your schedule. This is second cons we have. Then there is also coverage gap. As I told, 100 functional coverage, 100 code coverage is very difficult to achieve. Even in the modern SoCs, it's not able to achieve. We do the exclusions for that. Exclusion in the sense, we exclude the part of the code which is not able to, or which is not need to be checked. We exclude that, or a particular condition can't be possible to simulate in the particular simulation. So in that, we exclude that, and in that way we achieve the 100%. But if we have the AI ML algorithms which can give us a random stimulus data or the parsed data, and we can use that data to simulate or manipulate 100 functional functional and code coverage, it is a best way to achieve that. So we use for that AI ML techniques. There are few things that we repetitively check. Let's consider there is in the every test case you write, right? There are the few things that manually you need to debug. So it will go countless hours to check that. So for that case, as I told, we use ML algorithm. So I will give where two common examples, two successful products where we use the AI ML algorithms and make these products are now available. So fundamentally, what exactly we do? We do the automation, we do the intelligence, and we adapt it into the UVM framework at the end of it. So what exactly we adapt? We adapt the AI algorithms. So someone will ask, what are the names of that AI algorithms that we use, or what are the names of that machine learning algorithms that we use in the VLSI industry? So if I want to give the name and if you want to want to quick ramp up on that, then you can just search on Google about the few of the machine learning algorithm that we use. So we use the common algorithms which is available in the machine learning, which is supervised or unsupervised or semi-supervised. So top 10 algorithms in the machine learning are like linear regressions. You can search, you can see the logistic regression, also the decision tree, then random forest, then k-means, and SVM, nothing but the support vector machines. These are the common AI algorithms you guys can check. We use these algorithms. There are few algorithm logic which are defined and we use them. Now, this is the UVM verification with agentic language reference models. What exactly we do? We automate a UVM test bench creation. So let us consider you got a new design, right? And how you do that automation of the UVM test bench. And I mean, manually writing the whole test bench is not possible every time. So whatever the algorithms I told you, right? These are like agentic LLMs. Means they are independent verification agents, you can say. We can take the help of them from design specification. They will create the scenario. They will, with their algorithm logics, they will enhance the functional coverage. It is nothing but automated. But whole things can't be automated, that's for sure, because human interface is possibly required. Then we have the coverage closure techniques, right? As I told, 100% functional and code coverage not possible. There are particular scenarios we need AI to predict a coverage gaps to get a high accuracy. As I already talked, intelligent debug tools, AI tools will parse your RTL and give you a little bit idea about intelligent debugging or the root cause analysis. Then we have autonomous regression management. Let's consider you have specific test plans, you plan and test cases. Every week you will run a regression. Then there should be record that this week these are the failures, second week these are the failure, third week these are the failures. So intelligently, these are the self-managed regression, autonomous regression management. We use AI ML algorithm to let's consider 10 failures was there, then it should reduce to 7, then it should reduce to 6. Like that, it will go to the reducing manner. So to track this performance, we need autonomous regression management. Now, we have natural language verification interface, which is nothing but we use the neutral languages, right? So we use the demonstrating from verification insights, we use the AI agent and generative concise the verification report, right? Summarize what are the complex bugs we find out or dramatically improving the debugging efficiency basically when we go to the next project based on the previous version. Now, what are the success stories I told that AI has used and it got? So if you see, these are the two giants available in the industry. One is NVIDIA. Their AI accelerated GPU verification has deployed the AI-driven algorithms. So whatever algorithms I told you, right, that all algorithms are highly optimized and fast verification runs. So verification cycle. So if you see the before the GPU verification, they use the without AI. So we observe that 40% more efficiency. So these are the success story. So bug detection also in the pre-silicon validation stage, we find so higher the first pass silicon success. So no need to do the recycling of the designs or re-verification. Second is the cloud-based AI verification. It's the Intel's advanced processor verification demands where we do the intelligent regression management across the product variant. And what AI has done is AI has developed the cloud-based, means it has developed the cloud-based verification for a different products, right? So we use the AI agents algorithms. We see the regression test suits. We allocate the computer resource. We prioritize the test pattern globally in the cloud-based. But so here also we observed a 60% reduction in the regression runtime. So if you do that manual work, it may take more 60% time. And also we have resulted in the 45% improvement in the bug discovery efficiency. So it's like this AI success stories are already there. And apart from there are many AI-based success stories which are available. But as a fresher, I recommend you, whatever the algorithms available, like what I told you, you can take the note of that algorithms. And when you get some spare time, please spend on that. So you will get the insights. How can we use these algorithms in our day-to-day verification jobs? Because currently you are verifying very small designs, FIFOs, or if you consider some flip-flops or some small synchronous circuits, right? In that case, this might be not useful. But when we go to the industry where the higher abstractions levels are there, time to market is very less. We want to do the manual tasks reduction. That case, this algorithms is basically a game changers. So this is all about this, how you can do set your career path, how AI is used, and the clear insights about the design verification. So now I guess I'm open for the questions. I will stop sharing and I will open for the question. If you have any question, please ask straight away. Let us discuss more about the questions. So,
Uh, Hello,
who's,
sir.
yeah,
This is Nagesh.
okay. Let's finish the
Uh,
chat first. There is, yeah, Nagesh, please wait a minute. Let me finish the chat question. So,
okay, sir.
So there is a one question from Utsav. Can you please repeat the ML algorithm names? Yes. Linear regression, logistic regression, Nasu bias, random forest, K nearest algorithm, K mix, support vector machines. These are the common algorithms. I mean top 10 algorithms, you can say. Okay. The next question, Nagesh. Yes.
Yes, sir. Sir, getting into the VLSI industry is really tough in these days. I have applied various companies too. Uh, Currently, I am a final year BTech in NIT Kurukshetra.
Okay.
How can I approach the industry experts to get into the VLSI industry? Like I have various
So,
projects on RISC-V processor, and I have also done a project upon the AMBA protocols on SoC. Also a
okay.
project regarding CMOS inverter, where
Okay.
I have performed in DRDO. I have an internship experience in DRDO. I have an exposure to the CMOS inverter in the Cadence tools.
Okay.
Sir,
Okay.
as you
So
said that AI is evolving in the DV verification, like verification, right? So
yes,
I
yes.
also have an internship experience in the Elevate company, like has a machine learning intern. So
So
my question is, how can I demonstrate and how can I excel my these skills to the industries? Like,
Got your question. So this is the very I mean basic question everybody have here. So to do that, Nagesh, I can say, to answer the question, as you from the NIT, I heard right, right? NIT, right? You are from NIT, right?
Yes,
So in
yes, sir.
that case, I recommend you to check with your alumni network, connect with the people of the same design verification on LinkedIn, let your resume be on their message box, and it will go step by step. If your alumni network is strong, your LinkedIn network is strong, without a campus you need to struggle a little bit, but it's possible. But if you have the on-campus opportunities, then that will be the best way to go ahead.
Yes, sir. The few companies are already getting into the like placement drive.
Yeah, exactly.
Actually, the negative point of mine is I have a less CGPA. Even though
Yeah.
I have skills.
So in that case,
Uh,
you can find out the offline internship opportunities on the LinkedIn based on your criteria, right? And then you can try for the full-time opportunities later. So
okay.
basically, this uh, uh, average CGPA need to be maintained. But if you have less CGPA in any ways, then you need to show your skills on the little bit higher level, or you can say you have to showcase your work more on LinkedIn and reach to the common interested peoples.
Yes, sir. Thank you.
That
Sir,
is
can you
only
share
the
this
that
PPT at
is
the end of the session?
so I guess team will check on that. Silicon team will check on that, and they will get back
Okay.
to. I don't have any idea on that.
Okay,
Yes,
sir.
sir.
Thank
You
you.
can share it to us. We'll send in the channel.
Okay, thank you. Second question was there. Vivek has asked one question. Can you tell me from where should I learn a tickle language? Also tell me some high level RTL projects for the final year students. So Vivek, talking about the tickle programming language, if you Google a tickle programming on the Google, then you can get many resources. Even nowadays, YouTube has also few of the tickle language recordings available. You can refer that. But if you want to read from the book, then we have the article programming language reference book. You can download. It is freely available on Google. So talking about the some high level RTL projects, so it depends on your skills. You can start from developing a small FIFO, both synchronous and asynchronous. Once you done, you find you can able to do the FIFO successfully, you can go to the some serial protocols, you can go to the some parallel protocols also. You can try for the AXI, APB, or bridge between AXI, APB, or you can try for the if you want try little advanced level, then you can try for the DDR3, DDR5 protocols, right? You can take the specification sheet and you can find out the scenarios, and then you can develop the your environment. Already RTLs for them are already freely available, right? You can take a simple DUT or RTL, and based on that you can create a UVM environment for that. That is more than sufficient, Vivek.
Okay, sir.
Okay, next question is by Harini. Yes, which core skill should we focus on building that AI? Sorry, Harini, which core skill should we focus on building that AI cannot replace? This question is not clear, so I'm skipping that. How do we approach? Next is from Charan. How do we approach the alumni through LinkedIn? If you don't mind, suggest your ideas to approach easy to get more information. So Charan, for that, easiest approach is to whatever the work you are doing, you can post that work on LinkedIn. Then people of the similar mindset will also join or like your post. Eventually you will connect with the same mindset people. So only the way to do that is to showcase your work on LinkedIn. So if you showcase your few of the projects what you have done, and you can post that links, how people are doing nowadays, then you can grow your connections. If you grow your connections, then you will see the LinkedIn post which related to design verification or a job opening, whatever it is. So only the way to do that is to post your work, showcase the people what you are doing. Because now fresher entries is more in the industry, right? So everyone want to enter. For that, showcasing is your work is only the best way. Next question is by Sriram. Sir, can you plan another session like learning industry oriented design approach in Verilog? Yeah, I can plan. It's about you can check with your Silicon Sandbox. We can plan such session where we go deep inside into design approaches, right? We can see how the UVM environments are bring from the scratch in the industry and with a very less minimum time. Hi sir, this is from Khalid. Hi sir, I am recent batch students, had experience in VLSI front end. May I know when market is open for our batch? There is no any specific month or year that VLSI had job opening. This field is growing, evergreen, right? So there is no any specific months that you will get the jobs. It's always ready to open. You just be an active on LinkedIn. You act if you are college going students. If the companies are visiting your campus, please concentrate on basic aptitude skills and Verilog and system Verilogs as a fresher, and you are ready to go then. There is no any specific months or that you will get the openings very high. Sir, I am pass out. This is from Dipti Reddy. I am pass out graduate, currently working as a hardware test engineer. Okay. How can I get into VLSI domain? Can I take training? I'm applying for internship, but I'm not even getting response for any exam. For that, you need to first do training or without training is individual decision, right? But I recommend to have a training, right, with the coaching such as Silicon Sandbox, and you can try yourself to get the idea about common concepts. Once you are okay with that, you can try applying internship. You are not getting responses. It is a slow process for a fresher, right? You have to demonstrate your skills, and once you have demonstrated your skills and you are able to clear the first few rounds of interview, then it is easy to catch the market, but it will take some time. Okay, Charan, welcome. Next is Divyandra Shani Dhanraj. Sir, how can I get hands-on practice in VLSI domain with NVIDIA LLM? Okay, got your question, Divya Darshini. So for if you want to hands-on with the LLM NVIDIA, then you can officially visit the NVIDIA's LLM brochures, which is available on internet. You can see their machine algorithms. They have not posted all algorithms. They have few open source algorithms or the codes they have already posted. You can try reading that, or you can have the whatever the common repetitive things you are doing. So if you read that algorithm, you will get an idea how can we mimic that algorithm in our day practice. This is the only way you can use currently without exploring to the industry. Sumit Kumar, I need 2-month internship in DV. How can I approach companies and what do for maximum opportunity? So Sumit, for 2 months internship, the EDA companies can take a look. You can look at EDA companies like Synopsys and Cadence, but most of the cases only 11-month internship is available. So you need to rethink about how you can approach them. But as I told, you have to demonstrate your work first for the maximum opportunities. So next is how can we find internship, that I already told. Welcome from with me, Dipti, then Varsha. As getting into VLSI field right after BTech is difficult nowadays, should ongoing for MTech is best? Yeah, so this most of the you having this question that whether I go for training institute and join the service-based company or product-based company, what I get, or shall I go for MTech? So I recommend it's depend on particular individual to go for training or go for MTech. If you go for MTech, you have to spend another 1 year in the recursive courses, right? Or you have to clear the first gate examination and then you can try for the MTech programs. So that will eventually take time, guys, right? That will eventually take the time, right? So I recommend to have it's an individual decision whether to go for MTech or not. But if you are doing the MTech, the best possible way to go with the tier 1 or the tier 2 colleges. Going to the tier 3 colleges and eventually doing the course is not a good idea, but it's your choice or your skill sets or your times that restrict you. Next, as a fresher, it is sufficient to learn only Verilog system Verilog. Yes, you missed only digital electronic, Jansi. Please add the digital electronic skill. Then you are ready to go. You can also add one scripting language as we discussed today. Vivek Godbole, sir, how to take training at your institute sandbox? Sorry, it's not my institute. You can take the Vivek, the help from the team available at Silicon Sandbox and get into that domain. No, Vivek, I don't have any ideas currently for the PD domain, how to get into internship for that. Yogeshwar has a question. Okay, so he joined. Question says that he want to join DV now. He has previously prepared for some government job. So how can you? So Yogeshwar, there is no any shortcut to do that. You have to first spend initial 3 to 6 months, depend on your skills, on common approach like digital electronics Verilog, system Verilog, and UVM basics. Then you can showcase your work and you will get the opportunities.
Sir, hello. Hi, sir. Good evening, sir. Hello.
Yeah, Yogeshwar.
Sir, my question is that I'm 23 passed out. So, is that creates any problem for any companies hiring through policy? Because I'm a 23 graduate. So,
okay. So you mean career gap creates any problem, right?
Because I have preferred for government jobs, so that's why it is any career gap fluctuation happens to when I'm attending any drives or any an interviews. So
yeah,
they're gonna ask me that question. Wow. So yeah, passed out 23. So how can I that is it creates any problem or can I go on with join any?
Yogeshwar, usually it should not. If you have a strong skills, it should not create a problem. But I recommend you to make your basics strong first for VLSI rather than thinking that what we have done in the past. Okay, that can eventually wipe soon, right? So
yes, yeah.
So best approach is the coachings like Silicon Sandbox. You can join. You can refer their courses, right? And later, once you have the confidence, right, you can apply. So there is no. I don't think it will impact a lot.
Okay.
Yes. Next question. Yeah, Vivek, you can contact Silicon Sandbox for my LinkedIn profile. I don't have authority to share here. Okay. Then Renuka Dundarkar has a question. Dukhander, hello sir, I am 25 graduate student. You have good knowledge. That's good. I have done 2 projects. UART, okay, AHP design. I have applied so many companies, but still not getting any response. Okay, so Renuka, for that, only option is to showcase your work on LinkedIn and connect with the similar people, grow your connections, reach to the peoples in their direct messages, show your work in a precise manner in the LinkedIn. It will eventually go. It will take us time. It is slow process. It will take a time, but don't get demotivated for not getting response. You will get a response. Connect with your alumni, connect with your seniors. That is only the option currently. And you can do the coaching first, make the concepts clear. As you have good knowledge, then you can try more projects. You can see how you can use the whatever the machine learning algorithms I told, You can see the NVIDIA LLMs, you can see the Intel's AI cloud computing, how they are used. You try to get more understanding, showcase your work is the only way, Renuka. You can try that. So other peoples who are interested can reach to the Silicon Sandbox. I see no questions now. So we are done with the session. So if you have any
Hi,
questions,
sir.
yeah.
I'll ask you one question in chat box was about verification.
So may I know the question first?
Vamshi, as per the industry practice in a verification role.
You mean the what is the? I didn't get your question. Your voice is not clear.
Yes, sir. We have a question from him in chat box. As per the industry practices in verification role, once the RTL specification is available
Okay.
and we join the verification team, the typical plans include verification plan, architectural planning, and test plan development. Apart from these, are there any other plans or activities that should be considered?
Okay. It's a good question, Vamsidhar. As you mentioned, as I mentioned, once we get the RTL specification right, we as a design verification engineer, we create our test plan, right? We create the test plan, we see the features, we see the scenarios that we can cover. Okay. Apart from that, before writing the code, we think about the few of the data comparison logics that we can do in our project. So let us consider you have master at one end and you have receiver at one end, right? So if the in the complex SOCs, right, there are multiple agents will come into picture. There are the multiple modules will come into picture. So we do the cross comparison checks and we think about how we can do the scoreboard logics for them, because at the end we check end-to-end traffic in modern SOCs, right? So apart from the before the we go into the direct test bench development, we check the test plan. That is basic thing I told. We check for the any scoreboard logics we can add. We check for the any assertions we can add by our own. Apart from that, there is no any activities we do, Vamsidhar.
Okay, sir. Normally in the IP level, we use UVM for the verification, but in when it comes to the SOC level, they are preferring the system. Say, is really
Yeah,
doing
because
that?
yes, that's correct. That's correct because we mimic the processor traffic at SOC level, right? So we use the real-time processor traffic, so that managing the interrupts in the SOC is not possible with the UVM flow. So we use combo of UVM and C test cases, right? Basically at SOC we check for interrupts, right? So to check at the interrupt level traffic, we need a combo cases, which includes both. You mean seed cases also and UVM. But I didn't enforce to learn you C language. They are not a real time. They are just used for register read write. But if you have time, spare your time on C as well. If you are targeting the SOC verification.
Okay.
Yeah.
Thank you.
Yeah.
So, sir, there is a doubt to clear. Sir, has I have a internship experience in machine learning in my resume?
Yeah.
Will it be a plus point or will it be a negative point in my resume?
It will be positive point, but how you use that experience to demonstrate your skill in VLSI or a design verification matters, Nagesh.
Okay,
Means
sir.
how you can showcase that work or how you
Sir,
can make that work for a design verification will play the role now.
okay. If I
Yeah.
convert my experience into the design verification projects, like,
It's not
then
about
it will.
converting the experience. You can do some projects, right, first, and you can see then how you can use that skills, your ML skills for that. Like that, you can think. It's not like converting will work.
Okay.
Yeah.
Okay, sir.
Yeah.
Thank you.
I think team, we are done now. You have any questions for me?
No, sir. If we are done with the questions, then we can wrap up for today.
Okay. So no question now, right? Yeah, so thanks for joining this session. We are done for today. Thank you, guys. Thank you.
Yeah, before concluding, I would like to extend heartfelt gratitude for you, sir, for engaging the sessions and your patience for answering all the questions. Thank you all
Yeah,
for
yeah,
joining the sessions and being a part of this webinar. We can
yeah,
hang up the call now. Thank you, sir.
sure. Thank you. Thank you.
We also thank you, sir, for giving the exposure to DV verification.
Thanks, Nagesh.
Thank you, sir.